So our project is on reducing bias and toxicity classification. This is for CS224U final project. So the primary motivation for this project is to detect toxic comments in social media. It's one of the main areas of focus in artificial intelligence today, whether it be for hate comments, disrespectful comments, or generally anything that makes another user feel uncomfortable. However, a glaring issue in toxic identifiers is unintended bias. For example, bias detectors often associate terms referring to frequently attacked groups with toxicity. An example is the term gay might be deemed as toxic even when used in a non-toxic sentence such as I'm a gay woman. It's more likely to be labeled as toxic by the classifier. So the problem that we addressed was also proposed by Jigsaw's Unintended Bias and Toxicity Classification Challenge. The data that we use consists of around 2 million public comments made on Civil Comments platform. The datasets include a target toxicity level for each comment, which corresponds to the percentage of human raters who characterize that comment as toxic. That is either very toxic or toxic, with the other two possibilities for raters being hard to say and non-toxic. So our approach can be broken down into 3 areas: toxicity classification, bias detection, and reducing bias. As for toxicity classification, we used a Torch Shallow Neural Network as the baseline classifier for our model. For this, we achieve a macro average F1 score of 0.666 on the classification task. We also looked at a BERT model put forth in the paper Multi-Label Text Classification using BERT. BERT is a transformer-based model that is frequently used in toxic comment classification. Ultimately, 99.31% accuracy was achieved for identifying toxic comments. Also inspired by the paper Unified Deep Learning Architecture for Abuse Detection, we use GloVe pre-trained word embeddings in toxic comment classification, employing 2 classifiers or classification paths that allow for the use of more diverse data rather than solely the use of word vectors. This method proved to have an accuracy of over 93%. GloVe, unlike BERT, is context independent and therefore combines all senses of any particular word into the same word vector. We also looked at specifically identity attack classification, which was one of the forms of toxicity used in the dataset. Identity attack is specifically toxic comments that refer to a user's identity and how they insult them. So we focused on using the NLTK word tokenizer and stemmed it using the NLTK snowball stemmer for English. As for bias detection, as stated before, our Torch Shallow Neural Network achieved a macro average F1 score of 0.666, only training on 5% of our total data so far since it is such a large dataset. As shown in the diagram, there is no substantial bias of the system when comparing false positive rates on general toxicity in the data. For our other models, we focused our attention on bias and identity attack, which, as I specified above, is considered a specific kind of toxicity prediction. So we focused on using 2 main methods, which are the shallow neural network and BERT shallow neural network and the bag of words method. So far, the bag of words method appears to be more successful. We conjecture that it has less bias since the features are not contextual across the board on all identity labels that we looked at. We think the bias is higher in contextual models since they learn association between all the words they're trained on. We therefore suppose that character level embeddings would have even less bias. Our next steps for this project are to continue to refine both the toxic classifier and the bias detector. We will continue training and introduce more complex models to the identity attack toxicity classifier. And as for bias mitigation, we'll experiment with data augmentation to mitigate bias in models, and experiment with different embeddings, such as character level embeddings, which we suppose would have less bias to start with. Thank you.